Good morning, good afternoon, and good evening, wherever you may be watching this from. My name is Mayas Levinda, and I'm going to explain additional mathematics vectors. This is all you need to know to pass additional mathematics vectors. Firstly, I'm going to start with what is a vector? A vector is purely a numerical quantity that has a magnitude and a direction. So we'll look at a vector and a scalar. A vector has magnitude and direction. An example of a vector can be, we can say 14 kilometers per second, that is velocity. Velocity, which is a car moving at 14 meters per second. So per second can also be done like that, or 14 meters per second. Alright, then there is a scalar. A scalar is a numerical quantity that only has a magnitude. So we can say, for example, temperature. Maybe the normal body temperature, it is 37 degrees Celsius. This is a scalar. We can say the weight of an average human being, somewhere 60 kilograms. This is a scalar. It is just a numerical quantity that has a magnitude, that's all. Then a vector, of course it has a magnitude, which means it has a size, but it also has a direction. For example, when a car is moving, it can be moving northwards. Maybe a car is traveling between cities. It's going from Chilabombo, it's going to Lusaka. It will be moving northwards. It depends on the compass. So this one has aspect of direction. You can be moving northwards, you can be moving southwards. You can be moving eastwards, and you can be moving westwards. Any of these directions. So that's the first thing. That is a vector and a scalar. Then we have notation of vectors. Notation of vectors. Here, a vector can be denoted or denotated in the following ways. It can be denoted, for example, we can have letter A. So this is the letter A. But for this letter A to become a vector, we can say an arrow just on top of letter A. It means letter A is now a vector. We can write it like this. Letter A is now a vector. We can also use the bolded format of letter A like this. So this is very hard to do using a pen. Therefore, I do not recommend we do this. Maybe when printing lesson you can use a bolded letter A, because it's very hard for you to be writing a bolded letter A when you're writing your vectors. The fourth way is like this, with a line just underneath the vector. That's the fourth way of denoting a vector. So these are the four main ways of denoting a vector. That is how we represent our vectors. Then from there, we have to know the magnitude of a vector. When we hear the word magnitude, it kind of means size. Even before learning about physics, magnitude means size. For example, we may hear somewhere on the world there's an earthquake. There's an earthquake with a magnitude of 8.5. That's a very high magnitude. It means the earthquake was very strong. It's just trying to say that that's the size of the earthquake, the intensity of the earthquake. So that's what I'm trying to say. So magnitude of a vector is like the size of a vector. It is the modulus of a vector. So if we have vector A, B, and then we want to write the magnitude of the vector, it will be vector A, B, like that, with 2 bars. So the arrow just means we're going from A to B. This will be explained in later videos. Then if we also have the first way, we can denote the vector like that. Vector A, we want to find the magnitude of the vector. It means that we will do it like this. A with bars. It means we have now found the magnitude of the vector. This is what we call the magnitude of the modulus of a vector. The formula will be explained later, but yeah, so the formula will be explained later. We just end there on the magnitude of a vector. But there is something that we need to note. There is something we call a zero vector. It is noted like this, or like that. So like this or like that. So this, just from the name, is because we are saying it's a zero vector. Why is it a zero vector? It is because it has a magnitude of 0. So it has a magnitude of 0. And of course, if it has a direction of, if it has a magnitude of 0, it means it has no direction. So that's what we need to know under the magnitude of a vector. Then there is also the next one, which is the scalar multiple of a vector. So like I said, a scalar is just like a number, certain quantity, but we're saying scalar multiple of a vector. So here we can say we have the vector B like this, like that. That is a line segment. When we put that, it becomes the vector. It has no name, so now this is vector B. So we can reduce vector B to just become a bit smaller, like that. That is vector B. Now, we can have vector RS. Let's do it like this. Here, starting from R, starting from going to S, starting from R going to S. This is it to B. So RS is equal to 2 of vector B. So we have vector B here. RS is 2 of the vector B. So we can compare vector B and 2 of vector B. This number here, this 2 right over there, that is what we call the scalar. So for example, if we just had RS like this, and we can see the lines are in the same direction. They are parallel. That's one thing to note. And prior to this, we did not know all of this that we have answered. We just knew this is vector RS, they're in the same direction. We would know that vector RS is equal to K of vector B. So this K that we have denoted here, this is a scalar multiple. That's a scalar multiple. It's like the scalar multiple of the vector B. So here, this K is a scalar. It is a scalar. That K. Scalar just means it is a number. So that K is a scalar. It can be positive. It can be negative. So how can a scalar be negative? So we can give an example of that. When we said 2b, 2 of vector b prior, we said 2 of vector b. The scalar here, it was positive. That's 2, 2b. This 2 was positive. It was positive. Now, we can have a situation where we can have the vector b like that, as we can see. So the vector b is like that. And then we have the vector. So this is the same size. The vector negative b. What can we say? The scalar here, it means it is a 1, but k is equal to negative 1. So what am I trying to say? The difference here, there's a positive 1 in algebra, the one that we cannot see, the positive 1. And then here, there is a negative 1, negative 1b. The k is negative 1. That is what I'm trying to say there. So, from there are two things that we need to note. We can have a scalar. Now, when we have two vectors, they can be parallel and in the same direction. Again, we can have two vectors. They can have the same magnitude, but in opposite direction. So these have the same magnitude or size. So they both have a 1. Like the unit length, or how long they are, it's like a unit length, which is just 1. Now, that is the size. The only difference is in opposite directions. The one where we had the 2a, it means that it has, of course, the same direction because it was positive. They are moving in the same direction, they were both moving up. But the magnitude is different. It is twice the magnitude of the other vector b. That is the scalar multiple of a vector. Then we move on to addition of vectors. Addition of vectors. So we have addition of vectors. So when we look at collinear points, this video is going to go all the way looking up to a concept that we call collinear point. So now we have reached something called addition of vectors. How do we add vectors? How do we add vectors? So I'm going to give a vector. This is vector RQ. And then we have another vector going down like that. Vector RZ. Now, if you are told to add these two vectors, alright, let me just break them down first of all. We have vector RQ. This is R, this is Q. Then we have vector RZ. RZ. So there are two vectors. You are given a question like this. There are two vectors like this. And then they tell you to add them. So, here, we're going from R to Q, we're going from, then here from R to Z. What I've done is like, this is the tip. If you don't want to say tip, you can say head. This is the tip or the head. This is the tip or the head. Then this part here is the tail. So you arrange them tip, this tip to that tip. You put them like that. It will take us to the first method of adding vectors, which is called the parallelogram rule. That's what it's called, the parallelogram rule. So what do we do in this rule? In this rule, we can remove the letters like this, and then what we'll do is that we'll extend this part here. Have you seen this part? So we're going to extend this. We put it up here. So this here is going to go up there. That's step number one. The bottom vector is going to go up. It will look like this. So this will go like that. Then this vector that is pointing up will go here. I don't know if that makes sense. So the first thing, this will go up there. And then this is going to go like that. So it's going to go like that. And then, since this was RQ, this was RZ, we have extended this to there. There is something we call the resultant vector. The resultant vector is the vector that is going to be passing right in the middle. So this vector here, this one that I've just drawn just straight there, that is the resultant vector, and that is how you add vectors. So the resultant vector will come about as a result of adding these two vectors, which is we can call the resultant vector. Maybe we can call C, vector C is equal to RQ. So it's like you're saying this side is now parallel to that side, and this side is parallel to that side. Or if you don't use arrows, maybe it might be confusing. Too many arrows can confuse others. This side is parallel to this side. This side is parallel to that side. They are parallel. This side is parallel to that side. This side is parallel to that side. So this is like another RQ here. So C, if you want to go to this vector that is C, RZ, ZQ. So RZ, ZQ. That's a way you can use the parallelogram rule. The second rule it is called tip to tail. Tip to tail. So tip to tail. Head to tail. This is the same thing. Tip to tail, head to tail. So the tip can also be the head when we're talking about vectors. So we are going to just elaborate using the same examples. RQ, RZ. We have the vector RQ. RZ. So RQ and RZ. And then, now we are asked to add these two vectors. We'll put them in such a way that they are tip to tail. So you can do this in two ways. We are saying there is RQ, RZ. So this tip, like I said, tip to tail. This here, we can write this vector right like that. Or let us just maintain the format. So this is RQ, RZ. Let me just erase the RQ for now. RZ was going like that. Tip to tail. So this is the tip. This is the tip here. And then RZ, let me just write it again so that people don't lose it here. Or RZ, depending on how you want to say it. So RZ, here it's RQ. This tip to that tail. It's like lift this vector up. And you remember the arrow was there. So this is Q. So it was RQ. RQ. Now we put the RZ there. This is the resulting vector. So we'll connect these two lines and we'll do it like that. So this vector that has come about will be vector C. And if you remember with the first method, vector C will be equal to you adding whatever this is, whatever letter is here, let's put J, let's put K. How do you add vectors? So you say vector C, which is this one there, is equal to Rj. Rj plus Jk. So if you really look at that, it's like you're going from R to K. But it's like you rest. You are resting at the letter J. R, J, then J, K. That's the second method. Tip to tail, head to tail. That's the method for adding vectors. So that's your addition of vectors. Then we have the position vectors. After we look at the position vectors, we'll talk about collinear points. So, position vectors. Position vectors, we can have our x or y plane, just like that. Our x or y plane. Marker is not very visible. This is our y, that is our x. Then here we have our origin. So, a vector. You can draw a vector. For example, you put a letter here, J. So the difference with this vector, it is starting from the origin, it is going to the point J. That's a point coordinate J. J maybe can be 1, 2, or something like that. The coordinate is not needed. What I'm trying to say is O, J. So any coordinate, whatever you have been given in your exam question, maybe let's carry the same 1, 2 is equal to. So I'm going to introduce a new way of writing vectors. Vectors can be written like this. Maybe vector RC is equal to x, y. This represents x movement, y movement. The movement in the x-axis, the movement in the y-axis. Or a coordinate, an x-coordinate, y-coordinate. Alright. So here we have 1, 2. So since we have a coordinate, we can just say 1, x, 2 for the y. That's our OJ. So have you seen a difference? I was saying things like R, Q. But this one is starting with the letter O. The letter O. It means these vectors, they start from the origin. They go, maybe you can have another vector like that. We can have S. We can have another one like that. Can be K. So these are all different vectors, but they have one property that is the same for all of them. They are all position vectors. So that's what we need to know under position vectors. It's just an introduction. This video is an introduction to vectors, to just get familiar with what you asked under vectors, but we have examples. We are going to have answering different examination past papers. Okay. So the next one is collinear points. Collinear points. What is this all about? Right, so if you've looked at coordinate geometry, that is your grade 10 coordinate geometry, you can have a line segment, a certain line segment. Line segment is just, I'm just meaning something like this. K as a point, so we're going to mark that as a point. R as a point. We're going to say Z and then P as a point. These are just all different points. Let me just put a dot there on the P so we do not get confused. If we look at this, it is divided into 3 equal parts. There's K, R, R, Z. Hopefully you can see that. K, R, R, Z, Z, P. Or Z, P. Whatever you may want. What am I trying to bring out? This is a line segment. And it has different points. So collinear points are points that are on the same, that lie along the same line segment. What is so special about them? So we talk about a slope. There's something we call a slope. Slope means gradient. Slope. This slope, this is like a positive slope. When you think about calculus, this is a positive slope. Or coordinate geometry itself. The positive slope. Now, this slope has the same gradient here. So, right over here, the gradient here, M, is the same. The gradient here is the same. Here, there, it is all the same. The gradient is denoted by M. You don't need to know this. This is an introduction to vectors. So I'm not focusing on coordinate geometry. But if you're preparing for additional mathematics, you need to know this. So the gradient M, it is the same. It is the same. That's what we're trying to stress. So collinear points have the same gradient. Now, before we end the video, I want to bring out something else. We can have a line segment like this. And then we have a point here. We have the point, we can say B, the point F, and the point G. And then they tell you that BG, F, is the midpoint. The midpoint of BG. and then BG is equal to, right, this is just an example. This is just an example. I'm saying BG is equal to A, we can say 6A, 6BG is equal to 6A plus C, 9B. That is our BG. And then F is the midpoint of BG. And then they tell us. And then, okay, we know, if they just tell us in the question that F lies on BG, such that F is the midpoint of BG, and BG is equal to 6A plus 9B, they're trying to say that these are collinear points. What's the difference about collinear points? They are separated by certain scalars. I think you have got that one. Certain scalars. So we have a scalar, BF, BF, BF. Let me write it here. BF is equal to half of BG. Because if you read the question, it's saying BG. Now, BF is equal to half of BG. Because F is the midpoint of B to G. So there, all the way to there, F is like on the middle. That's what they are trying to say. So BF is equal to half of BG. This means it will be half of 6 of vector A plus 9 of vector B. That is what we are trying to say. 6 of vector A plus 9 of vector B. So, this means that if they told us to go from F to B, F to B, you know, this is still half. But we're going in the opposite direction. We're starting from F, we're going to B. It means it's going to now be a negative half of 6A, 6 of vector A plus 9 of vector B. Then if you want to know FG, FG is also the same. It is also half of 6 of vector A plus 9 of vector B. So that is what you need to know about collinear points. Because since we knew that F is half, we talked about F being half. It means that this here is equal to that there. So this part is equal to that part. It's divided into 2 parts. Thank you for watching this edition, this video. As usual, my name is Mayas Lubinda, and see you next time.